Hello children, today we are going to discuss about the relations and functions. In the previous video already we discussed about the relation, but to refresh your memory again I am going to discuss, then later on we will discuss the types of relations. So a relation R from a non-empty set A to non-empty set B is a subset of A cross B. A cross B means Cartesian product. So relation is always a subset of A cross B. In other words, any subset of A cross B is a relation from A to B. Like R is the subset of A cross B. And R will be what? The ordered pair. But the first component of this ordered pair must be compared the first set. And second component must be compared with second one, because A cross B we are writing. So one example I am taking. With the help of this example, we can understand relation. See, let's suppose there is a set A. The element of set A is 1, 2 and 3. If we write A cross A, means A cross A. What we are doing? A is the element of set A is 1, 2, 3 and A. We are writing the Cartesian product A with A only. So A cross A, 1 into 1, 1 into 2, 1 into 3. Like similarly 2 1, 2 2, 2 3, 3 1, 3 2, 3 2. So this is A cross B. What we want to this relation? Means in a relation, this condition must be satisfied. Means the difference of the first component and second component must be equal to V. And this R, just see now from here only, if you will take R, what will be the which order pair will come here? Difference. See, 1 minus 1 is not equal to 1, so you cannot take this. 1 minus 2, it will give you minus 1, so it's not equal to 1. 1 minus 3, minus 2, 2 minus 1. So this is your first order pair is 2 minus 1. 2 minus 2 you cannot take because 2 minus 2 is not equal to 1. 2 minus 3, 2 minus 3 you are doing is equal to minus 1, which is not equal to 1. So this cannot be. Now here 3 minus 1 you are taking, that is difference is coming to, but we want 1. So this is not possible. So second one is 3 comma 2. So this is the relation R which is going to satisfy this condition. Means the difference of the first and the second component should be equal to 1. So this is your R. This is the relation is there only. Okay. Now we will discuss the types of relations. In types of relations, we will discuss empty or the void relation, which relation is known as a empty or void relation. Second, we will discuss universal relation. Third, identity relation. Fourth, reflexive relation. Fifth, symmetric relation. Sixth, transitive relation. Seventh, equivalence relation. And at last, we will discuss the equivalence class. Equivalence relation and equivalence class are different. Here we will discuss equivalence relation and equivalence class also. So first two I am taking empty and universal set. See, empty relation you can say, void relation you can say, or null relation you can say. Which relation is known as empty relation? A relation R on a set A is called empty relation if no element of A is related to any element of A. Means whatever the relation is coming, that should be empty. Means there should be no pair which is the subset of A cross A. One example I am taking. Let's suppose there is a set A. The element of set A is 1, 2, 3. So we are supposed to write down the A cross A Cartesian product first, because already we know that relation is the subset of the Cartesian product. So A cross A means 1, 1, 1, 2, 1, 3. Similarly, 2 1, 2 2, 2 3, like 3 1, 3 2, 3 3. Now relation is given. What is the relation? Relation is given here only. AB such that A minus B should be equal to 10. Means what? The order pair which are given here only. This A, this is the B. The difference of this one. See now, here is 1 minus 1 is not equal to 10. So this is will come in R. Similarly, 1 minus 2, 1 minus 2, this is also not equal to 10. 1 minus 3, this is not equal to 10. Similarly, 2 minus 1 is not equal to 10. So if you will go none of them will come in R because the difference of the first component and second component is not equal to 10. Means in whole set, in all pairs, AB you are taking is not a subset of A cross A. So therefore you can say here is R is an empty relation. In this R, you will not get even a single order pair which is going to satisfy this condition. The order pair must be satisfied this condition. So none of the order pair in this A cross A is going to satisfy this one. So therefore you can say in this relation no order pair is there, so that is the empty. So this is the empty relation. Now second one is universal relation. Universal relation. A relation R in a set A is called a universal relation if each element of A is related to every element of A. Then R should be equal to A cross A. Means A cross A is the subset of A cross A. Means all the sets must be there only. All the set must be in R. Just an example. Same set I am taking. Here A is equal to the elements we have taken 1, 2, 3. So A cross A you will write, you will get this one. Now the relation is given here A minus B such that modulus of A minus B must be greater than equal to 0. So you must check the order here like 1, 1 you are taking. 1, 1. So A is 1, B is 1. So 1 minus 1 is greater than equal to 0. It is going to satisfy this one. You will get 0, 0 is greater than equal to this one. Second one you are taking 1, 2. 1, 2. So this is 1 minus 2 is equal to, you can say, minus 1, and this is also greater than 0 because minus 1 means 1 is greater than 0 is there. So one of the conditions is going to satisfy. So similarly here is 1 minus 3, minus 2 is 2, 2 is greater than 0. Any one of the condition should be satisfied. So you can see here only for each and every ordered pair, this is the condition is going to satisfy. For all the ordered pair, this is the condition is going to satisfy. It means what will be in R? All the ordered pair from A cross A. Then you can say this is your universal relation. So to become a universal relation, all the ordered pair from A cross A must be in R. Now third, we will discuss the identity relation and reflexive relation. But sometimes these relations are also known as a trivial relation. Now we will discuss about identity and reflexive relation. Okay. Now we are going to discuss the identity relation and reflexive relation. These are the two very, very important relations. You should try to understand. This is very, very important relations. Identity relation. A relation R on a set A is called identity relation. Identity relation generally is denoted by like IA. If every element, look at here, if every element of set A is related only to itself. Remember, look at here. These are the two important words you should be very careful here. Every element of set A, like the set A we are taking 1, 2, 3 elements is related only to itself. That is known as the identity relation. Like the relation we are taking R, A to A, where A, small a belongs to capital A. Means every element of set A must have a relation with itself. Like here you write A cross A you know, that is 1, 1, 1, 2, 1, 3 is already we discussed. Now identity relation, what will be the identity relation? 1, 1, 2, 2, 3, 3. This is an identity relation. Is an identity relation. This is your identity relation. Here is every, look at here now, every element of A is related to only to itself. खुद खुद का खुद से means doublet. You can say the doublet is here. Doublet here. Her element, every element. Doublet doesn't mean that only one and two have a relation. No. Each and every. So this is an identity relation. One more example I have taken. Suppose your relation R1 is here. For the same set, we are taking 1, 1, 2, 2. Is not an identity relation because here is 3, 3 is not given. So this is not an identity relation. Here another example I have taken R2, 1, 1, 2, 2, 3, 3. Means the element which are given in this set A are already here. Doublet is here. But one more, look at here now. This one more, 1, 3 is extra, So this is also an identity relation. Because identity relation is every element of A related only to itself. खुद का खुद से 1, 3 खुद का खुद से नहीं है 1, 1, 2, 2, 3, 3 they are related to itself. So you can say also identity relation is a kind of relation which contains the elements related to itself only खुद का खुद से, that is an identity. A minor difference is here between identity and reflexive relation. So now reflexive relation. A relation R on a set is called a reflexive if each element of set A is related to itself. That is your reflexive. Like we are saying A का initial relation. But this A, this is for all. A small a belongs to capital A, means the elements belongs to this one. So example we are taking, like there is a let set A is there, elements are 1, 2, 3. A cross A you will write because relation is already you know that relation is the subset of Cartesian product A cross A. So A cross A you will write, this is the A cross A. I have taken from here. Now I am saying this R is the relation. In this relation order pair are 1, 1, 2, 2, 3, 3. So this 1, 1, 2, 2, 3, 3. This is a reflexive. This is a reflexive relation. And here another I am taking suppose 1, 1, 2, 2, 3, 3. And one more 3 is also there. This is your extra. So then again this one is also reflexive. This is also a reflexive here. Because reflexive means that is a kind of relation which contains the elements related to itself, but as well as can contains other pairs too. Means in any relation, all the ordered pairs should be there, whichever doublets should be there, and any one of the element of set A may have a relation with another element. So we are not worried. Means see, look at it now. Itself as well as can contain other pair too. There may be other pair also, but to become a reflexive, doublet should be there. Even a single element of set A should not be which have a ordered pair, which does not have a ordered pair. So this is also a reflexive relation. So the difference is here only. Look at here now again to understand. To become an identity relation. See, this is 1, 1, 2, 2, 3, 3 is an identity. 1, 1, 2, 2, 3, 3 we are also saying reflexive. Here is R2 1, 1, 2, 2, 3, 3 1, 3. We are saying this is not an identity relation. But here 1, 1, 2, 2, 3, 3 1, 1 we are saying this is reflexive. So which may have this one. Here is this is the extra because here is every element related to itself only खुद का खुद से then 1, 1, 2, 2, 3, 3. And so finally one more thing we are getting is here that every identity relation is a reflexive relation, but converse is not always true. Now we will discuss about the symmetric relations and transitive relations. Okay, now we will discuss the symmetric relation. Which relation is known as a symmetric relation? So a relation R on a set A is called a symmetric relation if for every belongs to set A, then A is have a relation with B. Whatever is A have a relation with B, A or B should be also be in R, B or A for every A belongs to A. Just see, you can understand with the help of the example. Let's suppose there is a set A whose elements are 1, 2, 3, and if you write A cross A, so A cross A is 1, 1, 1, 2 like this one. We are taking a relation R. The relation R, this is given. Now we want to check whether this relation which is given here only is a symmetric relation or not. See now, this is given 1, 2, 3, 1, 2, 1, 1, 3, 3. This relation is symmetric. See how 1 is related with 2, 1, 2 belongs to R. If we interchange this one, means A or B, B or A, just we are going to 1 have a relation with 2, then 2 must also have a relation with A. So 1, 2 belongs to this set R, 2, 1 is also going to belongs to this one. Similarly here, 3, 1 belongs to R, and 1, 3 must also be in R, must also be in R. Any order pair which you are taking, agar 1, 2 belongs to R को, then 2, 1 must also be in this one. 2, 1 must also be like here. Similarly, here is 3, 1. Then 1, 3 is also here. So you can see this is the relation which is the symmetric relation. Now when the relation will not be the symmetric, just see this, you can look at here. AB are the element will belongs to A. AB belongs to R. But BA means just if we interchange this one, should not belong to R. Example, let's suppose there is a relation R is given. Now we want to check this relation. जो ये relation given है, the relation which is given here only, we want to check this relation is not symmetric or not. See, here is 1, 2, then 2, 1 is also here in this R. 2, 3 is here, but 3, 2, 3, 2 is not in R. So therefore you can say this is not symmetric. This is not symmetric. So to become a symmetric, the order where the elements are given like 1, 2 is 1, 2 belongs to R. Then if we interchange them, must be also be in R. Then only you can say this relation is symmetric. Now next we will discuss anti-symmetric. Okay. Now anti-symmetric relation. Which relation is known as anti-symmetric? With the help of the example, we will try to understand, because sometimes the children are very much confused about this anti-symmetric relation. So I have taken a set A, the element of set A is 1, 2, 3. I am taking three relations R1, R2 and R3. We will try to understand which relation among these three is anti-symmetric. See, this R3, this relation R3 is a anti-symmetric relation. Now why this R3 is a anti-symmetric relation? So for this one, R is anti-symmetric, means any relation will be anti-symmetric relation if A is not equal to B, then both AB and BA cannot belongs to R. Cannot belongs to R. One of them belongs to R, but both cannot be. So why we are saying this R3 is the anti-symmetric, because 1, 2 and 2, 1. 1, 2 is also going to belong to R3. 2, 1 is also going to belong to R3. And what here we are saying, AB and BA, means AB is going to belong to R, any one other relation. Then if we interchange, then should not belong to that same relation. If they are not going to belong, then you can say here is 1, 2, 2, 1 is also going to belong. So that's why this R3 is not anti-symmetric relations. Now next we will discuss the transitive relation. Now the transitive relation. A relation on a set A is called transitive relation if AB belongs to R, BC belongs to R. There is a relation R. AB is order pair which is going to belong to R, and BC is also belong to R. Then see now, first component of this order pair and the last component, the second component of this second order pair, AC must also belongs to R, and this is true for all ABC, belongs to capital A, means set A. The elements which are given in A set A, ABC of the element must also belong to this one is there. Or you can write it in this way: A have a relation with B, B is have a relation with C, then the same relation must A should have C. For example, suppose if I am saying A is the brother of B, then B is the brother of C, then A must also be the brother of C. Then this relation will be the transitive. Suppose A is the brother of B, B is the sister of C, means whatever is the relation here and here, same relation must be here. If A is the brother of B, B is the brother of C, then A must also be the brother of C. But if this condition is not going to satisfy, then you cannot say. You can say this relation is not a transitive. So example I am taking, let us say there is a set A, the elements are 1, 2, 3. A cross A, addition product will be right, this one. Let's suppose these two relations I am taking. Now we will try to understand in these two which one is the transitive, which one is not the transitive. This relation R1. Here is 1, 2 belongs to this A cross A. Then 2, 1 also. 2, 1. Here is 1, 2. 1, 2 and this second 2 have a relation with 3. Then 1 must also have a relation with 3. 1, 2, then 2, 3. Then 1, 3 is also here. So this is a transitive relation. This is a transitive relation. But this see the R2 is here. 1, 2, then 2, 3. Then 1 must have a relation with 3. But this 1, 3 is not here. 1, 3 does not belong to R. This is not an R2. Does not belong to R2. It means this relation is not a transitive relation. Now next we will discuss equivalence relation. Okay. Now the last is equivalence relation. Equivalence relation. A relation R on a set A is called an equivalence relation if it is any relation will be the equivalence relation if it is reflexive. Second, symmetric and transitive. Means all the reflexive, the relation is reflexive as well as symmetric as well as transitive. Then only we can say it is an equivalence relation. Equivalence relation means these three, reflexive, symmetric and transitive, all the conditions, all the relation must be satisfied at the same time. If it is reflexive, symmetric and transitive, then only you can say that relation is an equivalence relation. Now second is the equivalence class. This is very important to understand what is an equivalence class. Let R be an equivalence relation. There is R which is an equivalence relation is there in a set A, and let A belongs to capital A, then the set of all those elements of A, all those elements of set A which are related to A is called the equivalence class, and that is determined by A and it is denoted by this one. This is the notation. This is don't think this is a greater integer function. This is not a greater integer function. This is the we can denote the equivalence class by this symbol. Then A is equal to V belongs to A, but AB belongs to R. AB belongs to R, and there are the 2 points are there. 2 equivalence class are either disjoint or identical. If you are going to find the equivalence class, then either they will be the disjoint. 2 equivalence class we are going to find, then either they will be the disjoint or will be the identical. But this equivalence class you can find only in case there is a equivalence relation. And equivalence relation are on a set, it partitions the set into mutually disjoint equivalence class. Now example we will take. With the help of the example you can understand in better way equivalence class. So next we will discuss the example. Okay children, now one example I am taking.
this example will help you to understand that actually the meaning of the which relation will be the reflexive, when will be the relation will be reflexive, when will be the symmetric, when will be the
transitive, which is there already. Means with the help of this example, we will try to understand the reflexive, symmetric and transitive. So to refresh your memory again, reflexive relation is A have a relation with itself only. A R A, but for all A belongs to capital A, means all the elements should be there, like A belongs to R. In symmetric, A R B, then same relation with B R A. Or you can say if AB belongs to R, then if we interchange, that order pair must also belongs to R. In transitive, A B belongs to R and BC belongs to R also, then AC, first component of this order pair and the second component of this order pair must also belongs to R. Then you can see that relation in the transitive. So let the example we are taking here, let there is a set A whose element is 1, 2, 3, 4 and there is a relation A to A is there. So you can write the A cross A 1, 1, 1, 2, 1, 3, 1, 4 like that, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, yes you can. And we know this R is also the always the subset of A cross A. See, here I am taking few example I am taking, relations I am taking, this one relation I have taken R, another relation is R, and here is another relation R is there. But this all we are taking from the set A. Elements of set is 1, 2, 3, 4 is there. Now we want to understand this relation which is given here only is reflexive or symmetric or transitive. We will check for reflexive. How can you check for the reflexive? To become a reflexive, already I told you, every element of set A must have a relation with itself. So 1, 1, 2, 2, 3, 3, 4, 4. So look at here, this 1, 1, 2, 2, 3, 3, 4, 4 is given, 1, 1 is given, 2, 2 is given, 3, 3 is given, 4, 4 is given. It means this relation is reflexive. So you can say yes. Now we will check for the symmetric. To check the symmetric, see, forget the doublet. Forget this doublet. 1, 1, 2, 2, 3, 3, 4. Forget that. Just you must check here. Like for 1, 2, 1, 2 belongs to R. Then 2, 1 also must belong. So 2, 1 is also going to belong to R. See, similarly here is 2, 3. 2, 3 is belonging to R. But 3, 2 must also belong to R. But 3, 2 is not belonging here only. It means this is not a symmetric. This is not a symmetric because here is 3, 2 does not belong to R. So that you can say that it's not a symmetric. Now we will check for the transitive. For the transitive, we need more exercise. इसके लिए we should be very careful because to transitive AB belongs to R and BC belongs to R, then AC must also belongs to R. So here we are supposed to check for each and every order pair. If you want to leave, you can leave these order pair like doublet. You can leave it is 1, 1, 2, 2, 3, 3, 4. Leave it this one only. Just look at here now. 1, 2 belongs to R and 2. 2, 2. See now here. Second component is again related with this one. Means 1, 2 and 2, 2. 1, 2 belongs to R, 2, 2 belongs to R. Then first component of this one and second is this one is there. First is this, second is this, that is 1, 2 and 1, 2 is already belongs to R. So it is true for this 1, 2. Now similarly for this one 1, 3. 1, 3. Here saying 1, 3. Then 3. 3, 3. Then first component of this one 1 and then 3 is already here. So that is, it is true for this one also. Now you can take for this one 2, 1, then 1, 2, 1, 2, then 2, 1. Look at here now 2, 1, then second component have a relation with this one 2, 1, 2, then first, then 2, 1, then 1, 2, then 2, 2. So 2, 2 is also here. So that is also the true. So likewise, you are supposed to check for each and every ordered pair. Remember, then also you can say it is yes. So this is the relation which is reflexive, transitive but not symmetric. Now we will check for The second type relation we are taking. See now, here 1 1. The elements in a set is 1, 2, 3, 4. So 1 1 is here, 2 2 is here, 4 4 is here, 3 3 is not here. So this is not reflexive. That is no. Because 3 3 does not belong to this R. Now symmetric. See, 1 2, then 2 1. 1 2, then 2 1. So it is true for this one only. There's no need to check these doublets. You are supposed to check for the which are not the doublet. So 1 2, then 2 1. So that is symmetric. So you can say yes. Now you must check for the transitive also. See now. For transitive, again same 1 1. You are not supposed to check for this doublet. Just check for this one. Now here 1 2, then 2 1. Then 1 1 is also a relation. Here is there. So that is true. Here if you want to check this one also, that also you can do. You can take like this. There only like for example you are going to check for this one. Suppose then 2 2, then 2 1, 2 2, 2 1. Here we are taking 2 2. Suppose you are taking 2 2 and then 2 1 for the second will be here, then this one. So what do we get? 2 1 is there. 2 1 is the relation. Then again it should be what? It should be 2 1 and 2 1 is already given here. 2 1 is already here. So that is it is true for all. So then we can say this is transitive. We can say yes. So this is the one of the way. Likewise, third part is also we are taking. In the third part, in relation we will check whether it is reflexive, symmetric or transitive or not. See now, here is our elements are 1, 2, 3, 4. So here is 3, no doublet is here. So this is not so reflexive because 1, 1, 2, 2, 3, 3, 4, 4 does not belong to R. So this is not reflexive. Now we will check for symmetric. 1, 2, interchange, 2, 1 is also belongs to R. So it is true for this one. Check here, 3, 1, 1, 3. So 1, 3 is not here. So this is no. Because 1, 3 belongs to R. But, sorry, this is 3, 1 belongs to R. But 1, 3 does not belong to R. So this relation is not symmetric. Now see the transitive. Same. Here is 1, 2. 2 1 1 2 2 1. Now we will check for 1 1. So 1 1 is not here. So this is not transitive. So you can say this is no. Like here you can say 1 2 belongs to R. 2 1 belongs to R. But 1 1 does not belong to R. So that's why you can say this is not a transitive. So most important point is here only. If you want to check for the transitive, you must check for each and every ordered pair except the doublet. If you want to leave the doublet, you can leave it. But you must check for each and every ordered pair. Then only you can give the comment whether it is a transitive or symmetric or reflexive. So this is one of the best way to understand reflexive, symmetric and transitive. Now we will discuss the questions.